Welcome to the session. I am Dr. Anusha Kathyayani, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering. Today, we are going to see about the corrosion. What are the processes involved in the corrosion and what are the types of corrosion and the mechanism of corrosion. So, we are going to focus on introduction to corrosion, followed by factors affecting corrosion and types of corrosion and theories of corrosion like acid theory of corrosion or dry or chemical theory of corrosion or galvanic or electrochemical or wet theory of corrosion. We are going to see in detail today. First is the introduction. So, what is corrosion? So, the corrosion is a process of gradual destruction or deterioration of metals by the reaction of chemicals or by chemical attack or electrochemical attack on the of environment on a specific metal or this which are metals are a surface of a metal or a metal oxide layer by the chemical attack. The deterioration of this layer or the gradual destruction of this layer is called the corrosion. If we see in the industry, all the parts are corrosive because of the environment, which is the electrochemical attack of environment of this specific metals, mostly the iron metals, the brass metals, and the alloys of iron ore, which are frequently exposed to the very different chemicals, which makes them to corrode. It becomes corrosive because of the electrochemical attack in the by the environment. So, what are the causes of this corrosion? So, the metal exists in their ore forms, which is a stable form. During extraction, ores are reduced to metallic state by the energy supply. Then the isolated metals are regarded as metals in their excited state. So the natural tendency to go back to their state, which is called the combined state, causes the corrosion. So the ore is exist in this form. So the ores are reduced to metals. So the ore is existed in earth surface. The ore may be the iron ore, the metallic ores which we get from the earth's crust. So they are reduced to metallic state by supplying energy, metallic state. So these are more highly susceptible to corrosion. So the corrosion product will be, so in order to change back from their position, like this metal state to ore state, it undergoes the corrosion reaction. So what are the effects of corrosion? What are the effects of corrosion? So the wastage of metal in the form of its compounds, because the layer is destroyed or deteriorated because of this corrosion. So the wastage of metal is wasted because of this corrosion. So the valuable metallic properties like conductivity and malleability and ductility are lost. So due to this corrosion, it loses the unique properties. So like conductivity, malleability and ductility, this type of properties are lost due to this corrosion. And also lifespan and efficiency of the metal is reduced in machinery because of this corrosion. So what are the factors affecting corrosion? So the nature of metal, and next is the nature of the environment surrounding it. So the first is the nature of metal. So it mainly depends on the purity of the metals and the physical state of a metal and position of galvanic series and position in its electrochemical series and nature of the oxide film. So this nature of the metal depends upon whether it is anodic or cathodic. So if it is anode, it is more reactive, cathode less reactive to the corrosive products. So it depends on purely on the position of galvanic series and position in electrochemical series and the nature of the oxide film forming on it. Next, the nature of the environment surrounding these metals. It is in which the material is kept, means the environment surrounded by the metal also influences the corrosion process. which is the pH in the environment as well as the temperature and the pollutants in the atmosphere, and the moisture means the water content and the dew. So the water or the humidity present in the environment and the humidity. So this causes the problem of corrosion on the metal. So this corrosion is of two types. One is the nature of metal and next is the nature of environment. Under the nature of metal, it depends on the electrochemical series and galvanic series, the position in its the position of the metal in this series and the purity of the metal. Whereas in environment pH, temperature and humidity and dew and moisture are pollutants in the atmosphere. So this is the galvanic corrosion table. If we see here from magnesium to gold, here this is the anode. So anode means highly reactive. Cathode means less reactive. So the metals present in the anodic side will react very highly, and metals present in the cathodic side means lower series. Here the it will be very less, means less reactive. So the areas of anode and cathode. So the cathodic area increases, corrosion increases. So anodic area increases, corrosion decreases. So here cathodic area increases, the corrosion decreases. The anodic area increases, the corrosion decreases. So the cathodic area increases, the corrosion increases, and the anodic area increases, then the corrosion decreases. And the third one is the purity of the metal. So the high pure metals has less corrosion impurity. Increases corrosion increases. So the high pure metal means corrosion decreases. Here impurity increases means this corrosion increases. So because it depends on the purity of the metal. So there is no impurities means there won't be the corrosion. If the metal is very impure means the impurities content is more, the corrosion will be more. So the impurity increases, corrosion increases. The impurity decreases, the corrosion decreases. So the next is the nature of the environment. So first is the temperature and the rise in temperature. So temperature increases, the corrosion due to increase in rate of diffusion of ions. So here the temperature increases, the corrosion increases, and the humidity of because the diffusion of ions increase, the rate of diffusion of ions increases. Then humidity and moisture. So this humidity and moisture acts as a solvent for oxygen, carbon dioxide and sulfur dioxide and produce electrolytes. So they produce electrolytes which increases the corrosion. So the pH, the lesser the pH, greater is the corrosion. So it is inversely proportional. So means the pH is very less, the corrosion will be high. The presence of impurities and suspended particles in atmosphere. So the corrosive gases like carbon dioxide, sulfur dioxide and hydrogen sulfide and vapors of acids. So the less pH means acid. So the acid vapors increases the electrical conductivity and thereby increasing the rate of corrosion in this type of metals. So what are the types of corrosion? Generally, there are three types of corrosion, but we are comparing the dry corrosion and wet corrosion right now. And what is dry corrosion? Dry corrosion is it occurs in dry condition. Wet corrosion is it occurs in wet conditions. So if the corrosion takes place by the attack, which is a direct chemical attack, in the absence of moisture, because it is a dry corrosion, it is carrying out in the dry conditions. This corrosion is known as a dry corrosion, chemical attack. Here, coming to the wet corrosion, it is by the electrochemical attack in presence of moisture. Means the wet conditions, means in the presence of humidity or a conducting medium, it is called a wet corrosion. It is explained by absorption mechanism, whereas this wet corrosion is explained by electrochemical mechanism. Here it occurs in both heterogeneous and homogeneous surfaces. Whereas if this wet corrosion occurs only on heterogeneous metal surfaces. The corrosion is uniform, means if the corrosion is taking place, it will be the uniform all over the metallic surface. Here the corrosion is not uniform because it may occur in any part of the metal, it won't be the uniform, and it is a slow process. This dry corrosion is a slow process, whereas the wet corrosion is a fast process and not uniform. This is slow and uniform process. The corrosion products accumulate at the place where the corrosion occurs. Here, it will dry corrosion. Whereas in this, the corrosion takes place at anode and products near the cathode. The accumulation of the products will take place near the cathode. So this is the differences between the dry corrosion and the wet corrosion. So if we see here, no medium or no humidity. So this is the dry corrosion, and you can see the uniform. So the corrosion is uniform all over the surface. The corrosion is uniform, and it is heterogeneous. It occurs both on heterogeneous and homogeneous surfaces. This dry corrosion. Whereas wet corrosion, it is surrounded by water. We can see here the water. So it is surrounded by the water or a medium which is called conducting medium, and that is the moisture condition. And we can see this is the heterogeneous metal surfaces. It occurs on the only heterogeneous metal surfaces, and it is not uniform, and it is a fast process. We can see here the wet corrosion process. So the next theories of corrosion. So there are three theories of corrosion. There are three theories of corrosion. One is acid theory of corrosion, and next is dry or chemical theory of corrosion, and third is the galvanic or electrochemical or wet theory of corrosion. So these three theories of corrosion we are going to see in detail. So here we can see the galvanic corrosion, and this is the acid theory of corrosion, and this is the electrochemical or wet theory of corrosion. So coming to the first theory of corrosion, which is the acid theory of corrosion. So here the corrosion of metal iron is due to the presence of acids in it. Acid theory. So the name itself indicates this corrosion occurs due to the presence or the involvement of acid in it, around it. According to this theory, iron, which is a metal, is corroded by the atmospheric carbon dioxide, moisture and oxygen. So the iron is influenced by the atmospheric carbon dioxide and the oxygen and the moisture. So the corrosion products are, this is iron, FeHCO3 taken twice, and FeOHCO3 and FeOH3. So the iron hydroxide compounds are reacted with the carbon dioxide and the oxygen and the moisture, results in the formation of this rust, which is nothing but this is the corrosion. So the iron reacts with the 2 carbon dioxide and H2O and half O2, results in the formation of FeHCO3 taken twice. So which reacts further with the water molecule and half oxygen, which gives 2 FeOHCO3 plus 2 carbon dioxide molecules and 2 water molecules. This formed product is FeHCO3 taken twice, iron bicarbonates plus water gives rise to iron hydroxide. So which is FeOH3 plus 2 carbon dioxide, which is a hydrated ferric oxide. Means hydrated means it reacted with the water, oxygen, moisture present in it, which gives the formation of the rust, which is called this corrosion. So which is here the formation, this what happens, the carbon dioxide and the water present in the environment resulted in the formation of carbonic acid, which is called H2CO3, and Fe plus this iron reacts with this carbonic acid and results in the formation of FeCO3 and hydrogen. So this is the involvement or the reaction of the presence of acid causing this acid theory of corrosion. So the iron is going to attacked by the iron, this hydrogen, carbon dioxide and the moisture, means water. So this results in the formation of this carbonic acid formation, which further attacks the iron, results in the formation of a final product rust, which is the corrosion. So the next theory of corrosion is dry or chemical theory of corrosion. So here this theory states that corrosion is due to the reaction of atmospheric gases such as oxygen, halogens and sulfur oxides. So this theory states because these metals are reacted are going to attack by the atmospheric gases, namely three gases: oxygen, halogens and these sulfur oxides. Halogens are chlorides, fluorides. So and these sulfur oxides, etc. So there are three types of again dry corrosion. One is oxidation corrosion due to oxygen. If it is causes only to the oxygen, so if it is causes only through the oxygen, then it is called this is the oxidation by corrosion due to oxygen, and corrosion by other atmospheric gases and liquid metal corrosion. So if the corrosion by other atmospheric gases, then it is called the corrosion by other atmospheric gases, then liquid metal corrosion. We are going to see in detail this oxidation corrosion due to oxygen, followed by corrosion by other atmospheric gases, followed by liquid metal corrosion in detail. So the first is the oxidation corrosion, which is due to the attack of the oxygen on it. So if we see here, the oxygen present in the atmosphere attacks the metal's surface. So it results in the formation of oxide layers on the metal surface. We can see the oxygen molecules go and attack the metal surface. So the absorption of these metal ions on the metal surface, then here these are the oxygen molecules, they go and attack or attach it to the metal surfaces. Then these metal atoms on its surface, then absorption on the metal surface. The dissociation of this oxygen into atoms, then it continued, then it results in the formation of a metal oxide layer on a metal. We can see here the metal oxide layer formation on this metal. So what is the mechanism involved in this reaction? So 2M is the metal ion which loses its electrons, it undergoes oxidations, and then when it undergoes oxidation, the formation of ions will react with the oxygen molecules, then it undergoes reduction reaction. So here the overall reaction is the oxide layer is formed because the metal lost its electrons and the oxygen gained its electrons. The oxygen present in the environment it gained its electrons, then it undergoes reduction reaction and results in the formation of oxidation reduction reaction and the finally formation of the metal oxide layer on a specific metal. So the nature of the oxide. So when oxidation starts, a thin layer of oxide film will be formed on the surface, and the nature of the film decides the further action of the corrosion, that is which is maybe a porous or non-porous film. Here this oxidation of brass comes under the category of oxidation. This is due to the oxygen reaction on the brass metal. So the next oxidation corrosion nature of the metal oxide layer. So the metal oxide layer fine grained in structure and get adhered, means get attached to tightly to the metal surface. So if it is a metal surface, it tightly attached to the metal surface, this oxide layer. This is a metal. So it behaves like a protective coating. So this layer behaves like a protective coating. Suppose metal plus oxygen, this is the stable metal oxide layer. So there won't be no corrosion. Example, aluminium, antimony, lead and copper. So these are the metals which reacts with the oxygen and results in the formation of a stable metal oxide layers. So here the next is the metal plus oxygen, which is a volatile, unstable, so volatile metal oxide layer. Then evaporation of this metal oxide causes the fresh surface exposed for attack. Means when it reacts with the oxygen, the layer forming is unstable, means volatile. So which evaporates on some temperature condition or certain period of time. Again, the fresh layer of metal is exposed to the oxidation reaction. So the unstable metal oxide layer, So the oxide layer formed decomposes back to metal and oxygen. Example, gold, silver and platinum. They do not undergo oxidation, corrosion. So now coming to the porous metal oxide layer, if the metal oxide is porous, then it contains cracks. Means porous means it have some pores or cracks. So the atmospheric oxygen get penetrated into these pores present on the metal surface and corrode the metal. The example for this porous type of oxidation is lithium, sodium, potassium and magnesium. So coming to the volatile metal oxide layer, the example is molybdenum oxide layer. So the molybdenum oxide layer is the best example for unstable and volatile metal oxide layer. So it forms a layer on the surface and which evaporates, and the next layer of the metal is exposed to the attack. So the next layer is ready and the fresh surface is exposed for attack. So this is the different types on the nature of the metal oxide. So the oxygen reacts with the metal, forms metal oxide. Again, based on the nature of the metal oxide formed, these are the three types, namely stable metal oxide layer and unstable metal oxide layer, and third one is porous metal oxide layer. So the next is the volatile metal oxide layer. So which already discussed, which is like oxide layer formed on the metal surface is volatile in nature. Volatile means which evaporates into the atmosphere easily and evaporates, thereby leaving. So once the layer formed, if it is a layer, so it evaporated, then again this is the metal. So again this is the fresh surface which is ready for attack. So the layer, this is metal oxide layer which evaporates. So example for this molybdenum oxide layer. So the metal is ready for attack. So here the exposed surface plus oxygen, the volatile metal oxide layer formed on it, then the metal oxide volatilizes, and again here we can see the dots over here which is metal oxide layer. Then this metal oxide volatilizes and it gives the fresh metal. There won't be oxide layer. So another type is the porous metal oxide layer. So which is already discussed, which is the cracks present of pores present on the metal surfaces which penetrate. We can see here the pores on the surface. The oxygen present in it penetrates into these pores and results in the formation of the oxide layers. So which this example and corrode the metal. So the best examples are lithium, sodium, potassium and magnesium causes this type of porous metal oxide layer corrosions. So the next theory of corrosion is the dry and chemical theory of corrosion. So this is the corrosion. Here previously we have seen the corrosion by the oxidation reaction corrosion. Here this is the dry chemical theory of corrosion, which is the corrosion by other gases other than oxygen. It may be the chlorines and hydrogen sulfide, and this here the chlorides and hydrogen sulfide and other gases, like we can see the non-porous here under this category. There are two types. When Ag means silver react with the chlorine gives rise to silver chloride, which is a non-porous layer. Then iron plus hydrogen sulfide reacts with iron sulfide and H2 hydrogen, which gives a porous layer. In the tin and chloride reacts and forms a tin chloride, which is a volatile layer. Means when the attack by the other gases also forms a different types, porous, non-porous and volatile layer. So coming to porous, the gases can pause and continue corrosion. Whereas non-porous, the chloride film, here the chloride film, non-porous means silver chloride. So the chloride film is non-porous, cannot pass through the gas inside to the metal, and no further corrosion occurs. Means this porous means the layers, suppose this is porous layer, this is non-porous layer. So when it is non-porous, it won't allow the gas to pass through. So there won't be no corrosion. If it is a porous layer, it allow the gas to pass through, then the corrosion occurs. The corrosion occurs here, there won't be no corrosion. So this is the difference between the porous and non-porous layer. So example for non-porous or non-protective this in petroleum industry. The hydrogen sulfide gas at high temperature reacts with the steel, forming a iron sulfide layer, which is a porous layer. Coming to the volatile, which is resultant from the tin chloride, and this is volatile. Metal oxide is volatile, it evaporates. Same in the oxidation, when it is attacked by the oxidation, we have seen. So the metal plus oxygen gives the oxide layer, then evaporates, then again metal. So this is a volatile layer. Here, not this is not with the oxygen. This is with other gases. This is with the other gases like chlorine, hydrogen sulfide, and other atmospheric gases. So it reacts with the metal, reacts with the other atmospheric gases, results in the formation of a layer on its surface, which evaporates, which is a volatile and unstable layer, which evaporates and it is converted back into the metal. So the metal is again ready for the attack. So this is exposed to air. The fresh metal is exposed to air, and thus faster corrosion occurs. And another type is the liquid metal corrosion. So it is occurs due to the action of a flowing liquid metal at high temperature on metals or alloys or metallic ores. This corrosion is due to the chemical action of a flowing liquid metal at high temperature or solid metal or alloy. So this reaction involves either dissolution of a solid metal by a liquid metal or internal penetration, means internal attack or internal movement of a liquid metal into a solid metal. So this corrosion involves the dissolution of a solid metal. So the dissolution means dissolving of solid metal by a liquid, or the internal penetration means internal dissolution of liquid metal into solid. So it occurs by this process. This liquid metal reaction occurs by the dissolution of solid metal by liquid, or the internal penetration of the liquid metal into a solid. Maybe on the solid, it may occur from the solid to liquid or liquid to solid. So the liquid metal mercury dissolves most metals. So the mercury, as we know, the mercury will be in the liquid state, which is a liquid metal. The liquid metal is the mercury, which dissolves most of the metals. Even if we keep the mercury on a paper and we add 1 gram of gold or silver, it dissolves easily, because this has the capacity to dissolve the metals by forming amalgams, thereby corroding them. It is also a type of corrosion. So the dissolution of these metals is a type of corrosion. So when the mercury is reacted with the metals, it results in the formation of amalgam compounds. So the metals reacted with the mercury and results in the, so mercury plus metal gives rise to amalgam, means a corrosion product, because it forms the amalgams by corroding these metals. So this is about the chemical reactions taking place in the corrosions and the types of corrosions and the different types of corrosion by the atmospheric gases or oxygen and the liquid metal corrosion. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.